In question number 11, a piece of ice is floating in a liquid. If all ice melts, then I have considered this is a vessel and in it an ice is kept which is floating, and this is the level of the liquid. The density of the liquid is rho L. Now, if I find out the initial volume when the ice is floating, then the initial volume is the volume of the liquid. Let its volume is V naught. So V naught plus, if m is the mass of ice, then m divided by density of liquid. This is the initial volume of this system. Finally, when the ice melts, then the final volume is initial volume of liquid plus mass of ice divided by density of water, because now the ice got melted. So if I compare this, if the density of liquid is more, then the initial volume is less as compared to the final volume. So we can say that the level of liquid will rise if liquid is denser than water. So option 4 is the correct answer. Let's move to question number 12. In question number 12, the speed of liquid coming out of a small hole of a large vessel containing 3 liquids of densities 3 rho, 2 rho and rho as shown in the figure is. So if I apply the Bernoulli principle at this point and at this point, when the liquid just eject from the hole, then on this streamline I can apply the Bernoulli equation as P plus rho GH plus half rho V square is equal to constant. So I am considering this as my reference frame for the measurement of height. So at this point I can write atmospheric pressure is P naught, and this expression at this point can be written as 3 rho into GH plus 2 rho into GH plus rho GH. So net it can be written as 6 rho GH, and the velocity of the liquid at this point is approximately 0, as this cross section is very large, and that is equal to, when the liquid just eject out from the hole, atmospheric pressure is P naught, and this height gradient, this expression, the value of h for this is 0, and let the speed at this moment is half into rho is 3 rho into V square. So if I solve this equation, this P naught get cancelled out. The value of V comes out to be 2 times under root of GH. So option 4 is the correct answer. Let's move to question number 13. In question number 13, two light springs of spring constant 100 Newton per meter and 150 Newton per meter are connected as shown in figure. A block of mass m is equal to 6 kg is pulled slowly by a distance of 10 cm to right from equilibrium position. Then maximum velocity of point A indicated in diagram will be. So we have to find out what is the maximum velocity of this point A. So we can say that this spring constant and this spring constant are connected in series. So the equivalent spring constant can be written as K1 K2 divided by K1 plus K2. So the omega of this oscillation can be written as under root K equivalent by M. So if I substitute the value of K equivalent, that comes out to be 100 into 150 divided by 250. So on solving, it comes out to be 60, and the value of M is 6. So this comes out to be under root 10 radian per second. Now we have to find out what is the maximum displacement of this point A, and when the block is displaced by 10 centimeter. So let the extension in this spring is x1 and the extension in this spring is x2. Then we can say that x1 plus x2 must be equal to 10. Further, the force in these springs will remain same as the arrangement is in series combination. So 100 into x1 is equal to 150 into x2. So if I solve these two equations, the value of x1 comes out to be 6 centimeter. Now, in order to get the maximum velocity of point A, that is equal to omega into maximum displacement of A. So that is equal to under root 10 and the maximum displacement is 6 centimeter. So it comes out to be 6 under root 10 centimeter per second. So option 1 is the correct answer. Let's move to question number 14. In question number 14, in a resonance column experiment, the first and second resonance occurs at water levels 24.1 centimeter and 74.1 centimeter, respectively below the open end. The third resonance will occur when water level is at a depth of. So let's analyze the situation. Suppose this is a resonance column tube, and initially from this open end the water level is at a distance of 24.1 centimeter. So in this case the water is filled in this, and the antinode will form here and the node will form here, and fundamental mode of vibration is this. So if this length is L1, then in that situation we can write L1 plus E is equal to lambda by 4. Now in the case of second resonance, the arrangement is like this. The water level comes to this position. So in that case we can say that the arrangement is something like this. So this is lambda by 2, and it is given that this separation in this case is 74.1 centimeter. So we can say that the value of lambda by 2 from here is equal to 50 centimeter if I subtract 74.1 from 24.1. So again, in the case of third resonance, one more loop will come here and the water level has come to this position. So we need this much separation. So this much separation again is lambda by 2, that is 50 centimeter. So from the open end, the total distance of the water level is 74.1 plus 50. So it comes out to be 124.1 centimeter. So option 4 is the correct answer. Let's move to question number 15. In question number 15, a ray traveling in air is incident on a spherical body whose refractive index is root 3 at an angle of incidence 60 degree. The ray, after passing through sphere, gets incident on the further surface of the sphere and gets reflected and refracted. Then choose the correct alternative. So let's analyze the situation. Suppose this is a sphere and ray is incident in this way on this spherical body. So center of sphere is this. So the normal drawn at this point is this, and it is given in the question this angle of incidence is 60 degree. So at this point the refraction will occur, and if I apply the Snell's law at point x, then 1 into sine 60 degree, that is root 3 by 2, is equal to refractive index of the spherical body, that is root 3, into sine of the angle of refraction, that is sine r. So if I solve this equation, the value of r comes out to be 30 degree. So it means that initially the ray wants to travel in this direction, but the refraction occur at this point and the ray will bend towards the normal and will move in this direction. So it is something like this. It moves in this way and it incident on the further surface at this position. This angle of refraction is 30 degree. Now the normal at this point is drawn in this direction. So at this point the reflection and refraction both occurs. Suppose if I consider the refraction, then if this angle is 30 degree, then this angle is also 30 degree because this is an isosceles triangle, and the angle of refraction at this point will automatically be 60 degree as we have seen here. So this is the initial direction of ray when the ray moves from denser medium to rarer medium. it will deviate away from the normal and the ray will go in this direction, and this angle is 60 degree. Now if I consider the other case, that is reflection at this point, then the ray will reflected at this point, and if this angle is 30 degree, then this angle is also 30 degree, and at this point the normal will draw in this direction, so this angle is 30 degree, so the ray will move in this direction and the angle of refraction from the normal will be 60 degree. Now if I check the options, in option A, angle of refraction at first surface is 60 degree, that is wrong, it is 30 degree. Angle of incidence at second surface is 60 degree, it is wrong, it is 30 degree. Angle of deviation as ray comes out of the sphere is 180 degree. So if I consider this as my ray comes out from the sphere, then the angle of deviation is 60 degree, because here the deviation occurs delta 1, that is of 30 degree, and another deviation occurs here delta 2 dash, that is 30 degree, so total deviation is 60 degree. But if I consider this reflected ray, here is the deviation 30 degree, here is the deviation 120 degree, and again here is the deviation of 30 degree. All the deviations are in same sense, so the net deviation is 30 degree plus 120 degree plus 30 degree, so it comes out to be 180 degree. So option 3 is correct and 4 is wrong. So the correct answer for question number 15 is option 3. Let's move to question number 16.